Skywalk's unique glass floor. Engineers choose a glass made up of 5 layers. The layers are bonded together and laminated with a special adhesive to strengthen exposed edges and enhance clarity.
If they selected a glass and interlayer product, it would give a very clear view.
Each pane measures 4 feet wide and 10 feet long and weighs about 1,200 pounds. While the steel frame of the Skywalk supports its own weight and that of the glass, each pane of glass has to support a live load of 100 pounds per square foot, or about 800 people. This far exceeds the 120 visitors allowed on the Skywalk at any given moment. To account for gravity and wind loads, the composite glass is measured to support downward forces of 100 pounds per square foot. Skywalk's glass walls were originally designed to 7 feet high, but engineer Bill Caron fears this will feel too confining for visitors. So he proposes a height of 5 feet 2 inches.
Now the code only requires it to be 42 inches tall, so we decided on 5'2", so we were a little bit safer than the code, but you don't feel confined when you walk the Skywalk. It's very open.
Visitors are required to wear cloth booties, but even so, small scratches and scuffing of the glass is inevitable. Fortunately, the 5-layer composite allows for periodic replacement of just the top layer, lowering maintenance costs. The machine used to move the large glass panes during the original installation and for replacement is called a manipulator. Powered suction cups on a crane-like arm pick up the glass. The glass is then tilted 90 degrees for one last cleaning. The operator then gently lowers the pieces into place. While the glass is very strong, it is also very heavy and can break under its own weight if it falls or collides with rock or steel. The sheer weight of each pane presents a problem as the engineering team prepares to install the glass walkway. Because the box beams bend slightly under weight loads, the team worries that as each pane is placed, it will cause the steel to bend and possibly break a pane that's already been installed. Any miscalculation can result in a shattered piece of glass. To counterbalance the frame during installation, workers set out a layer of temporary steel plates to simulate the weight and size of the glass panes.
So we actually emulated the weight of the glass as if it was on there. So we went around and put steel plate on each section as if it was a piece of glass. So as we put a piece of glass on, we take a piece of plate off to make sure we had the right balance of weight. So it basically had that same bend, if you will, with all the glass on it at the end of the day.
There's one final consideration in securing the sheets of glass.